Fiction and reality. New stories, new ideas. Little Beth Entertainment.
Welcome to episode 102 of The Rocketry Show at TheRocketryShow.com. It's another great episode for you. We've got the University of Akron Akronauts joining us to talk about their latest launch attempts. We also have email responses from the last episode. We'll review those together as well at the end of the show. The Rocketry Show starts right after this.
Going up in 5, 4, 3, 2, 1, liftoff.
From Little Beth Media, a new podcast on model rocketry with build techniques, model rocket history, interviews with industry insiders, stuff for beginners and longtime model rocketeers, everything from low to mid-power. The Model Rocket Show with me, the Rocket Noob, at theModelRocketShow.com or anywhere you download podcasts.
The Rocketry Show would like to thank the following patrons for their support: Timothy Mock, Conway Stevens, Jeff Curtis, Phil Bridges, Scott Masters, Roy Tyson, Rob Hoagie, R. Smith, Gary Dow, Jay Pullman, Don J., G. Smearden, M. Erisman, Pierre Marlou, Jeff Curtis, Brian Lopato, Philip Calvin, Jay Bryan, Casey Anderson, Terry Dancer, Mark Essenwine, Jim Wilson, Jason O'Scally, and Scott Masters. If you wish to show your support and become a patron of The Rocketry Show, just visit us at support.theRocketryShow.com.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Welcome to the Rocketry Show.
All right, lift off and the clock is started. Yes, sir. Reading loud and clear.
A podcast that is all about advanced and high-power rocketry. Amateur-built rockets, starting at mid-power to higher-power versions. This program is hosted by the team who loves the smell of burning rocket propellant in the morning. Here are CG, Gene, and model rocket guy, Jesse Yu.
Welcome to another edition of The Rocketry Show at TheRocketryShow.com. I'm CG.
I'm Gene. And I'm model rocket guy, Jesse Yu.
Yes, and we're back. It's 2021. And we've got a visit from the University of Akron Akronauts. They went out to F.A.R. and did a launch attempt for a 2-stage rocket. So that's where they left it with us. So we're going to check in with the Akronauts and find out what happened. So,
can't wait to hear them.
Here we go. So we have on the show here Emily Armbrust, who is the chief cook and bottle washer for the gang here, the big one in charge this year of the University of Akron Akronauts. We also have Dylan Petty, who is the payload lead, and Blake Bowser, who's the chief engineer, Brian DiPolito, air structure specialist, and John Spencer, who is the avionics lead. And welcome to the program, everybody.
Hello, thanks for having us.
Hello. Tell us what you were heading out west for, and then we'll pick it up from there. So what was your objective?
So give a little context. We were supposed to launch our 2-stage rocket at the Space America Cup, or Spaceport America Cup, sorry. And that competition got canceled. So we were like, well, we still want to launch our rocket. So we took probably about 10 people. Some of them flew. Actually, everybody in this call hopped into my family's van, and we had a trailer, and we drove the 40 hours out to California to launch this rocket.
Did you go one straight shot, or did you guys do shifts in the van?
Oh yeah, we definitely took shifts, rotated out, went straight through, didn't stop.
Nice.
Yeah,
wow.
We laid down the back row in the van. I don't know if it's exactly State Highway Patrol approved, but we laid out a full bed in the back of the van completely. Everybody got 8 hours. It was amazing.
Cool.
Got to do what you got to do.
So you're headed out there, and where did you go, and what ended up happening?
Yeah, so we drove across the country. Conveniently, we have a couple of alumni who worked for TSC, Lockheed Martin, and Northrop out in Green Valley. So we ended up tent camping in their front yard for the week leading up to the launch. And like through the course of the week, conveniently, we were all allowed to like telework through our co-ops or like work our exams and our classes through our computers and stuff. So we could really drive out there and not be in Ohio. So throughout that week, we were all working and having class and then preparing a rocket in the evenings, which created like a hectic week. On top of that, like we would go on hikes and like try to sightsee a little bit while we're out there. Cause California, like some cool things to see. I'll pass it off to the guys to talk more in detail about like the prep of the launch week though. Blake, do you want to start?
Sure. Yeah. Like Emily had the great opportunity to stay at our alumni's home in Green Valley, California. We had, which was amazing because we could work out of their garage, which is something we weren't anticipating having the luxury of. Because if you guys have ever been out to the Mojave Desert, it's exactly what you would expect. Desert, there's nothing out there. There's nothing really to do. Just sit there and bake in the sun. Yeah, you get a lot of wind too. Yeah, we experienced that. But yeah, we got to work out of the garage, frantically prep the rocket. There was a couple errors that we had that we can go into further detail about later on. But the biggest one was we had our N1100 motor, which is the sustainer motor. It got shipped to us with a longer phenolic liner than it was supposed to have. So we didn't really know how to approach that issue because that's not something we had experienced before. We never typically have used N motors. So that was a big old mess. And moving through that problem was quite an experience.
Yeah.
And what'd you end up doing?
Well, we didn't end up trimming the liner like we probably should have. I guess the reason why we didn't do that is because going anywhere near the motor with a saw was probably a bad idea, considering that just a mile away there was a massive forest fire going just over like the mountain crest from where our alumni live. So if there was any chance of us setting our motor on fire and possibly setting their little town on fire, we weren't too keen on it.
Yeah, I bet.
Pretty scary. So we were kind of tiptoeing around the motor a little bit, and that caused a bit of an issue down the road.
Yeah, so there was like a discrepancy in the decision making of, since the phenolic liner was too long, do we screw in the nozzle all the way, or do we screw in the forward closure all the way, or do we do like half and half? And it was a huge argument between like the different leads and officers and then the alumni, because they have experience like actually in the industry. So we ended up deciding to screw in the nozzle all the way and not the forward closure. And unfortunately, when it came to launch day, the forward closure came off the casing, or blew off the casing, and the casing fell out of the rocket, and the like sustainer like came down ballistic. But yeah, so that was really unfortunate for like the result of what happened with the launch itself. But part of what added to the stress of like preparation was, like he was saying, like there was a forest fire like not too far away. So we packed up all of our things and put it all in the trailer. And then we also packed up like their household items, like all of their big belongings, like we had to leave.
Wow. Okay.
Town might. Yeah. So it was like really serious. So then we decided like the fire was getting taken care of, and we were like going out in groups to like check on it. And then finally we were like, okay, we can stay so we can go back to work. So that was crazy.
I can't imagine.
Yeah. Yeah. So like, and what we kind of realized through that process with that motor was, the error wasn't in how we chose to like deal with the issue right then, because like there was really like at that point, because we had no means to cut the liner, there wasn't much we could do. So I don't think any decision would have been the right decision then. We would have probably had the same issue. The error really lied in the fact that we didn't catch that issue while we were still in Akron, where we have a machine shop, and everything like that. And, it was almost like too far gone. So yeah, we're still unclear as to whether or not, we just didn't have enough thread engagement on the forward closure, and if it just blew off because it couldn't handle the pressure of ignition, or if there was like, because there was such a gap at the top, if there was like a reverse thrust or like a pressure buildup or something. But yeah.
Blow by around the seals because, yeah.
An old Rocketeer, and I don't even know like what it, where he got this information from, but he always guided me to screw in the forward enclosure all the way. And then the nozzle can do what it does. Now, I never questioned it, but I never asked why either. So I wonder if that has something to do with it.
Yeah, it took all of our avionics that were above especially like we had like our second stage like ignition avionics, like our tiltometers and stuff, like right above the motor, and it completely sandwiched it from, I think it was like 4 inches all the way down to like half an inch. And it took like a 1/4 inch aluminum bulkhead and like completely like bent it and warped it all the way. And it was very much, some interesting wreckage to go through. But yeah.
What were the specs on the overall mass of the rocket, and you had the sustainer as an N1100. What was the booster going to be?
The booster was an N5800, which burned perfectly. It was a beautiful launch up until the sustainer.
I launched that same motor out at F.A.R once.
yeah. We're actually planning on reusing it again for our spaceport launch in June. It's perfect for our 2 stages because we like putting a lot of cool payloads in. So that leads to heavy rockets, which means you need something like an N5800, But yeah, we pretty much, the full rocket weighed about 152 pounds and the sustainer was, I think, 80 pounds of that. So yeah, wow. So slightly top heavy, but yeah, we had a 15-pound payload in the nose cone that Dylan and I designed throughout the year.
Wow. 15-pound payload. Sweet. A bowling ball.
Yeah.
Yeah, it was cool. It was and I'll let Dylan explain some of it. It was really, really, really cool. Unfortunately, we lost it during the catastrophic events of flight. It's either, buried 8 feet deep in the desert or, impaled in a mountain lion. We don't know. So I'll let Dylan. Yeah, Dylan's our payload lead, so I'll let him, kind of go through that.
Cool.
Yeah, so the payload that we were doing for this year, we called it a submerged data concentrator unit. And we had like a computer cluster submerged in a dielectric coolant that was processing, I guess, like onboard flight data during the flight. And it was very much like a proof of concept thing. Like, could we have a sealed fluid environment, in the rocket? And it was just a lot of new stuff for us. And how the idea actually started was like this summer, like a year before that, a little bit over a year ago, we were watching a video on YouTube from a company called, I'm pretty sure it's Engineer Fluids, and where they had like this super, super nice like gaming computer in a fish tank. And they just like dumped it in the fish tank and then it continued to work. And we were really amazed by it. And we wanted to do something similar just because we thought it was so cool.
Yeah, was the fluid like mineral oil or?
Yeah, it's a mineral oil based. Then they have like different kinds, but they actually ended up giving us like a prototype fluid to like, I guess, test with. And it was super low viscosity, very similar to water, it was cool and it worked really well. But yeah, unfortunately we lost it after the flight.
That actually wasn't the only payload we lost.
We had another payload rocket that we also lost that was like right below the liquid payload. And I was going to have John Spencer explain his.
Yeah, so it was a CubeSat form factor, and it was a radio telemetry system. We call it RTS. So it was like a bunch of sensors that went to an Arduino, and it would transmit live data back to a ground station. It also had a Pi cam on it too, like a camera to record. So yeah, that got launched into the desert as well. Which on paper sounds great because that's kind of what it's made to do. So we get the data back. That's like kind of the whole point.
Right.
We discovered an issue with the way we were capturing the data, where it wasn't being saved as we went. We were using like a serial skimmer program to like read in serial data from the transceiver. And we had an issue with that, and we ended up losing the RTS data.
Oh no!
Which is just the icing on the cake.
Man.
Yeah. Part of like what made all of this fail too is like that, like on top of what they were just saying is like, we were prepared for a rocket launch, but like a 2-stage rocket launch in the desert with all of these nuances of things that were happening. Like they were finishing up the payload in the RTS, like in the car on the way there, like really bumpy road into F.A.R. If you've been there before, it's like 6 miles of like repeated just vibration.
Nothing. Yep.
Ridiculous.
Yeah. So like, and then we get there and we're setting everything up and doing the last minute, like figuring everything out, realigning switches that were kind of off. And then we get to the pad and there was a discrepancy with like aligning the rocket on the launch rail and when we should put the igniter in, if we should put it in like while it's on the launch rail or if we should have it like before we put it on. Well, it's 152 pounds. So we went to go put it on in 2 separate pieces, put the igniter in and put them together. Well, in trying to put it together, we cracked one of the launch lugs. So I had to take the whole thing back off and take it off and then just use, because we had several like locations where we could put launch lugs on just to be prepared. So we like added a different one, slipped the whole thing back on, reinserted the igniter. And the whole process of being on the launch pad was like upwards of 2.5-3 hours. So by that time, from the RTS data, we got that the nose cone was at like 140 degrees Fahrenheit, which is like not what it's supposed to be at all.
Yeah. Not optimal.
I don't know if you heard John, but he said it was a black nose cone. So, you know, thermal. So just to add all of that in. And as we were like tilting the rocket up, so it took like a group of people to like tilt the whole thing up because it was really heavy. And I'm stepping back to just kind of look at everything. And all of a sudden there's just fluid like running down the rocket from the nose.
Oh no.
And we're like, oh, we know where that's coming from.
And that was basic from the fluid overheating?
Well, we figured that there's what sucks about the fact that we never got our payload back is that we don't really know where the leak came from. We assume it was a thermal expansion because it was leak proof on ground. And it being 150 degrees up in the nose cone, which is where like the payload was located, we're assuming that that's what led to, especially that, like 3 hours of that, on the pad.
Right.
We assume that's what led to the heavy issue. And so, we're taking measures because we're going to redesign an optimized version of that in addition to some new payload concepts for the spaceport rocket. And we're pretty much just like, there's a lot of like new design concepts that we're exploring to minimize any sort of threat of thermal expansion causing any sort of issue, for any of our fluid systems. So what that just means is we're not going to use anything that the fluid touches is not going to be PLA. It's got to be metal. We're also like, looking into, different ways of attaching our sealant bulkheads, more O-ring seals, like whole bunch of real cool stuff. But it was definitely a learning experience. It was like, that was not fun. You spend like, a year designing a payload that's supposed to be sealed, and then you just watch all the fluid come down. It's just like, oh no.
Yeah.
At that point, what do you do? Right?
A lot of learning. At that point, it's launch it.
All right, we're going to take this moment right here on the program to take a quick break and take care of some sponsors. So we'll be right back with more of the University of Akron Akronauts right after this.
Hey, all you rocket geeks out there. Do you like doing in-flight videos of your flights? And do you ever use those keychain cams and unfortunately sometimes only get videos of your thumb? Hey, this is Gene from The Rocketry Show, and that used to happen to me. I used to use those old keychain cams only to get nothing very good quality. But I found a solution to that, and it's Insane Rockets. It's an app that's available on the Google Play Store for Nexus 5X and higher. Now get this, it does 4K video. But not only that, it'll upload it automatically to the cloud and provide you real-time telemetry while tracking your rocket through Google Earth. It is amazing. Available on the Google Play Store, Insane Rockets app. It's crazy. No, wait. It's insane.
It's time for eRockets.biz. eRockets.biz is your home for unique model rocket kits as well as the world's largest selection of rocket parts from Semrock. In business since 2009, eRockets.biz has a wide selection of your favorite kits as well as their own versions of popular out-of-production models many of you have come to enjoy over the years. And Jesse, you've been picking through the site, and what did you find this time around?
So I like going through eRockets and looking at all the updates that they put on the website. And one of the rockets that I'm really proud that they put up there happens to be model number TLM-RAM. And that particular rocket holds something special to me because Jason and Dave, when they were, kind of setting this rocket up, they brought us in to give some ideas on it. This is the Lock Ram. And the Lock Ram is nearly 4 feet tall. It's like 43 inches long. The tubing is something that they recently got at Lock Precision, and the nose cones, and it's like a 1.9 diameter tubing and nose cone. But the fins on this rocket, guys, is really, really cool. So I recommend that everybody go to eRockets.biz to pick one of these up. Right now, the price is really, really good. It's just around $50. They have a good stock of these right now. It comes with the parachute. It comes with a 29 millimeter motor mount tube. It comes with rail guides and launch lugs. So you can do low power fields, or you can do a rail and, stuff an H in there if you really want to. This one does come with a decal. And, the Lock Precision rockets are just good starter rockets. If you're looking to get into mid-power but still want to fly this on Ds, get the Lock Ram. You won't be disappointed.
All righty. Cool. And there are plenty of other rocketry items to choose from as well, such as educational rocket kits and supplies, air rockets, water rockets, and so much more. eRockets.biz certainly has enough kits and supplies to keep you busy in your workshop for a long time to come. If you need parts for your own custom builds, that's not a problem. eRockets.biz also supplies the Semrock line of airframes, nose cones, centering rings, motor mounts, and so much more. eRockets has more rocket parts available than anyone else on Earth. Check out eRockets.biz today to learn more. eRockets.biz. If rocketry scares you, buy a train set. The Rocketry Show would like to thank the following patrons for their support: Todd West, Matt Tudor, Les Rayburn, Steven Spencer, Paradise Rocketry, Bill Cook, Jason Cook, Gary Rosenfield, Greg Ziegler, Toby Vanderbeek, Ken Blade, Eric Hamilton, John Beans, Scott Holla, Guy Wadsworth, Phil D., Tom Rum, Michael Moore, Stephen Ray, Amanda Ho, Steve Sainer, Mark, RailButtons.com, and Todd West. If you wish to show your support and become a patron of The Rocketry Show, just visit us at support.TheRocketryShow.com. Welcome back to the program, and let's jump back into our interview with the University of Akron Akronauts.
What were your impressions of going out to F.A.R, Friends of Amateur Rocketry? Because I've been out there, and there's a gentleman out there, Rick Maschek, who I worked with, a great guy, and I'm just wondering what your thoughts and impressions were when you got there.
Yeah, they were great. We worked with Rick too.
Cool.
They were really informative, helping us do things we need to do. We were asking them the questions about the launch lug situation. We were like, well, can we have 2 launch lugs? Do you suggest we have 3? Yeah, they were great. We got to work out of a hangar, which we were also not expecting.
Those Quonset hut things, yeah.
Yeah. It was really nice that we had this huge space. They had tables, they had facilities there that we could use, tools and stuff. And actually, so it's like a 18.5-foot tall rocket. And we were like, we'll figure out how we're going to turn the switches on when we get there. And we went to go grab one. Yeah. We went to go grab one of the ladders, and it's like a 10-foot ladder. And we're like, that's funny. That only goes up half the rocket. So they had a crane, forklift thing that they drove over, and Ron got in it and lifted him up into the air to turn all of the switches on.
There's a picture of me 15 feet up on a on a forklift. Our project manager, John, right below me with the clipboard. It looks real sweet, and it's totally lit up my LinkedIn profile. I'm so excited.
That's really cool. So you're in the hangar and you're getting prepped and everything. And like walking it over to the pad, it's a bit of a distance if I remember correctly. So like how did you handle getting it out to the pad? And I mean, you already told us about what happened with the rail and the problems with that, but like how many people did you have lugging this thing? Did you take it in 2 pieces? How did that go?
Yeah, we had 3 people per stage and we carried it over in the separated stages. So it took like 6 to carry it over, plus like supplies to check the payload, because screwed that on at the very end just because of like manufacturing or assembly process. And then we turned those switches on first, like while it was still on the ground and stuff. But yeah, it was definitely a walk to get it out there.
And like when you did launch it, were the winds picking up in the afternoon? Because they typically like afternoon they start to get a little higher and higher and higher throughout the day. So like, was it really windy when you guys actually were ready to launch?
I don't think so.
No, we had occasional 5 mile per hour gusts, but it was pretty much zero at the time we were launching. So we were very fortunate for that. I think we ended up launching it at 3 p.m.
Yeah,
I think was the time. So we did get very fortunate.
Wow. Okay. So you loaded into the bunkers. Can you tell, like, because a lot of people haven't been out to F.A.R. Can you kind of describe what this place is like? I know what it's like, but I want to hear how you guys describe it and the launching area, like the bunkers that you're supposed to get in, all that stuff.
Yeah. I guess the best way I would describe it is, so like the hangars are just like, just like a classic, I don't know, it just looks like a classic aircraft hangar, but the bunkers specifically were like really, really cool. It was like, have you ever seen a movie when, I don't know, like in like a military movie, when they're about to like blow some stuff up, and everyone gets into the bunker with the little tiny binoculars, and then they go 3, 2, fire in the hole. Like it was like that. And it was actually really cool because we weren't the only launch that day. So we got to go, they would almost like sound the alarm every time there was a launch, and everybody would pile in bunkers and look through the little tiny window opening and, and launches. It was really cool. It was actually like an amazing experience because surprisingly, it almost seemed like we were closer to those launches, to those launch pads than like, for instance, like our NASA SLI competition, it's like a field away. So you're just like looking from far away. But yeah, we got to see some really cool stuff.
It kind of almost reminds you of like, what is it called? The TV show where they just like blow stuff up and they test things that are happening. Mythbusters, yeah. It was very so. Like where you drive out, like I said, on that really bumpy 6-mile road. Like there's mountains in the distance. Like you can see nothing other than just desert and like random plants, like desert plants. And then you got the bumpers on the ones, or the bunkers on the one side. You got the couple launch rails that aren't too far away from them at all. And then the rail or the hangars that you said were like kind of a farther distance away from everything, but very desolate looking. And then for the recovery of the rocket, I was kind of doing something, and then I saw everybody getting into the truck, and I was like, I ran over, and there was like 5 people in the truck bed and like 3 people in the back seat, and we're all just piling in with our camel packs of water because it's in the middle of the desert. And we just started driving. It's in that general direction.
Yeah, go.
So, yeah, honestly. So we dropped off some people to go pick up the booster, and they found it and they carried it all the way back, which was insane. They could have waited for the truck, but they carried it all the way back.
We did.
Yes, you did.
Wow.
That was fantastic too. So the ground there, if anyone's walking out there, you're like falling into prairie dog holes. Every other foot you step, like every step you take is crazy. And then there's all these like small holes, and you're like, if I stick my foot in that, I might get bit by a tarantula. And it's pretty horrible.
Not fun.
We walked at least a mile back to it might have been half a mile, like a mile, half a mile to a mile back to the launch site with the pretty heavy booster section, just like hanging over our shoulders.
Yeah. Well, it's hard to judge distance out there, though. I mean, it's like because everything looks the same, you can't get a read.
It's like being in Las Vegas. Everything looks like less than a mile away, and it's really like 5.
Oh no,
very much so.
Yeah. Oh yeah. we experienced that driving out there too. You would see Vegas off in the distance. And you'd be like, oh, we're almost to Vegas. That's like 5 or 10 minutes away. And no, it's like 45.
Yeah. And like when you were going through the recovery process of the rocket, did you come across any other orphans of the desert that they might have launched at a previous launch? Because we ran into 3 or 4 rockets that were just there. So we brought them back. But.
Really? That's nice. How kind.
We found bits and pieces of various rockets, but the one that stuck out to me the most, I remember I like fell in a hole and I got up and I saw a perfectly good 1/4-inch wrench just like in the hole. I was like, no way.
Wow.
Mine. I was taking that.
That describes it pretty well, I think, from my experience out there. So I've noticed that Rick has a kind of an interesting sense of humor. Did you guys pick up on that?
A little bit, yeah. Did he take pictures of you all the time?
No, because there was a BBC documentary filming when we were out there, and so we signed off on a waiver because they wanted to film us. And he was busy dealing with the BBC at the time, so he didn't take any pictures. They got some pictures of our rocket being with its fins shredding on a 5800N. So we didn't quite make it up to our projected altitude either.
We feel your pain.
Yeah. No, yeah, he carried a camera around, and it was really funny because like Blake and I were talking to him, and he just was listening, I think, and then Blake was like having this serious conversation. Rick lifts his camera up, takes a picture of his face while he's talking to him, just puts it back down and continues to listen. I was like, that's normal. Sure. Yeah.
Yeah, it is. That's cool. When you were there, do you know some of the history about that facility at all?
Yeah, Rick actually talked to me about it after I'd picked up the rocket. He was explaining that the facility was a military testing center at one point, and then they just up and left, like just pristine condition. They were just like, oh, we don't need it anymore. Someone else can buy this. So I'm not sure how many owners' hands it had come into, but eventually it found its way to the Friends of Amateur Rocketry, which I say is awesome, considering the cool things we got to do out there, and I continue to get to do out there.
And my students and I were talking on the way back. We said, we were like, well, launching in Ohio is going to be looking a lot smaller these days because there's all the test stands that they have out there, the facilities and everything. So I always say that once you've gone to F.A.R, that every other launch is going to be not as big for you because of the facilities. It's like going to Mecca almost, for rockets.
Mm-hmm.
Yeah. Yeah, definitely. If we end up running into a similar situation this year as we did last year with like competitions getting canceled, that's that we definitely really, other than the results of the flight, like everything pertaining to like the facilities and like, they were so, I guess like they were so like amazing to us, and we definitely go right back out there given the opportunity.
No, I recommend that everybody should go out there at least once and fly a rocket out there if they can.
Yeah. So we decided against doing the NASA SLI competition this year, just from like they're going online completely. And then also we want to focus on the Spaceport America Cup, like 2-stage rocket. And in the past, our Spaceport rocket's just kind of been like, oh, it's April. We should probably throw that together now. And the competition June. But now we have like the whole year to develop like really cool systems for this upcoming year. And I can let Ryan and John and Dylan talk about like their specific sub teams and what they're doing.
Yeah. So I would say so one of the biggest things that we learned from this 2-stage launch, and like, obviously you guys heard about like how long flight prep was and how stressful that was, is that like what we were doing is we were taking our previous single stage concepts and designs and just scaling them up to 2 stages. And that led to kind of a very stressful launch week and a very stressful launch with a lot of errors in it. It just, we didn't necessarily feel prepared going out there. And we found that a lot of the single stage design concepts that we had were just like not optimal when scaled up. So
sure.
What we're moving into, the big project that we're taking on, throughout this next year, is we're making our whole rocket modular. So, motor modules, parachute modules, avionics modules, payload modules, very, very much trying to like emulate industry. And that's going to allow us to do a couple things. A, like different parts of the rocket won't be dependent on each other. So we can, for instance, like the payload integration being like the last step of like our sustainer assembly, like on launch day, really kind of like held up our whole sustainer stage. Before we could actually like get the nose cone and everything on, we couldn't really like finalize that. So it'll allow us to like prepare different parts of the rocket independently and just have one modular interfacing point. And also it allows us to like, let's say we have a design that, doesn't exactly make it on time, towards the end of the year. Since all of our modular connections are going to be like uniform, we could just take that module out and sub in, and hopefully stability wouldn't be too bad. Like the stability change wouldn't be too bad. But yeah, no, it'll also, one of the things we're trying to do in order to grow as a design team is focus more on heritage hardware. So like, instead of having to rebuild the same systems every year and then get to the part where we innovate, we have the systems, we have the modules, we have like, for instance, like, 90 millimeter 6-grain motor module, that we could sub anything into that fits that spec, 6XL grain motor module. And we could take all those systems that we already have manufactured and assembled and ready, and those will be our modules. And then we can focus on innovating and improving the parts that need improved instead of like rebuilding the same rocket from the ground up every year. So yeah, it'll allow us to really take that next step into, not only emulating industry, but being more perfectionist, when it comes to, I guess like our full rocket design.
I heard modular design and I heard CG perking up.
I'll let Dylan give you a sneak peek of the payload, which we're trying to do this year too.
Cool.
Yeah, so one of the things that we're doing is we made the decision to rebuild the submerged data concentrator unit, just because it was a really cool system. Even like the week while we were there, like from the people at F.A.R, I got a lot of good feedback, and we think it would do well at the Spaceport America Cup. And so we already have like all the wiring schematics, the models for it, and we are redesigning it to be smaller and kind of like altering its function a bit. But so we are rebuilding that, and we're repurposing it instead of just solely kind of like collecting data from sensors and processing it. It's kind of going hand in hand with our new project that we're working on, which is a terrain mapping drone. And how the two kind of work together is, so like the drone will deploy from the rocket after landing and kind of do like terrain map the landing zone around the rocket. And it's going to send that like data back to the nose cone of the rocket where the submerged data concentrator unit will be. And there it will be processed, and hopefully we can get like those like 3D depth maps.
Nice.
It's like some cool visualizations from that.
And would you use telemetry to pick that up?
Yeah, we would.
Real time?
Actually, I don't think that part's been really like decided yet. I think.
Okay, sorry. I'm getting excited,
Yeah.
Yeah. But yeah, and then so with the drone, there's like various other systems. Like we have a rotational module that reorients the whole payload bay, so the drone's upright, and then like bay doors that open up and stuff like that. It's really exciting stuff.
Have you guys ever done a drone before?
Yeah, my freshman year, we did a drone for the NASA competition that like kind of deployed like a simulated GPS beacon type of thing. And it's very, like, there's a lot of good lessons learned in that. But so that drone is like very small, and like there were challenges to solve there. But what we ended up doing was it just flew out of the rocket, kind of like in the opening that is created from the parachutes. And it had like a cage around it to protect it. Whereas this year, we're like doing bay doors and doing like foldable drone arms to give us like a much more, I guess, complex drone, so we could do more with it.
All right. Open the pod bay doors, Hal, right?
Right. Or would you just call it a generic name? Concentrator, open the pod bay door. I'm sorry, I can't do that.
I'm not feeling it today.
Yeah.
My job is to collect data.
And then the last thing, we're trying to do like a flight computer, and I'll let John explain that.
Cool.
Yeah, so last year we did RTS. I touched on that briefly. And RTS was great. And we're going to do it again this year. We actually already have one of those boards reassembled, rebuilt. So we're going to keep doing that. But that's at like a breakout board Arduino level.
Mm-hmm.
And this year we're designing a flight computer that's going to be at like the microcontroller level. So we're going to use like an 18 mega, which is like the same processor they use on the Arduinos.
Mm-hmm.
So it's going to be kind of based on Arduino architecture, but it's going to be custom. It's going to have a bunch of pyro channels and a bunch of sensors on board. It's kind of going to do the same thing, except at like a surface mount level, never breakout board level.
Okay, so it'll be a central controller for all operations then, is that correct?
Yeah, pretty much. The goal is to make it pretty
Staging,
multi-purpose.
Okay.
Yeah, the goal is like so that we can program whatever we want it to do. So it'll have like an IMU and like a pressure sensor for altitude and a couple other things. And then like a GPS. And then, yeah, we'll be able to be pretty multi-purpose. So it could do staging, or it could do just like, it could work as like an altimeter and just do like separation for parachutes or whatever we're flying.
That's got to be rewarding. Good job, guys.
Thanks.
Thank you.
Appreciate it.
Still got some work to do.
Well, it always is, though. And the thing that I find, is you guys are just, what data do we get from the launch? You know, like we had a less than optimal launch ourselves, and like what went wrong, why did it go wrong? And you guys have the right attitude about going in there and doing some, failure analysis to find out exactly what that issue was and when did it happen and why did it happen. Just listening to you guys, it's like, that's part of the process, and you understand that, So we all know out there flying rockets that nothing goes completely the way you expect it all the time. And, just because that I'm not going to stop flying rockets because of it. That would be pointless, wouldn't it? So it's kind of cool to see that like at an engineering level that you guys are working at going through that same process of, failure analysis and mitigation. So it's pretty cool.
Yes.
I feel that we can hear your passion too, because you don't stop and you're looking for the next thing. Doing your homework, like literally doing your homework.
All right. So cool. Best of luck to you guys, and let's hope for some really cool stories as well as successes. But even if it's not, we got to get some cool stories out of it and things to learn as well, because that's good too. So we'll look for that from you guys next time. Thanks for joining us.
Thank you.
Thank you. Thank you very much.
Appreciate it.
Guys.
Thank you, guys.
Lock Precision Rocketry manufactures a full line of high-quality precision fit components to meet your building, repairing, and customizing needs. Lock Precision believes in making rocket kits as light as possible while maintaining the strength required to fly with commercially available motors. Lock Precision offers a wide range of rocket kits from the 1-inch diameter Lock 1 series to high-power rockets reaching 7.6 inches in diameter. When you visit lockprecision.com, be sure to check out their Performance Series kits featuring such designs as the Black Brand 10, the Caliper ISP, and the 3.1-inch diameter Iris rocket. All of Lock Precision's performance kits comes with everything you need, including pre-slotted airframes, high-grade precision-cut plywood fins and components, as well as ripstop nylon parachutes, rugged shock cords, polypropylene nose cone, and instructions. The name Lock Precision has been synonymous with mid and high-power rocketry for over 30 years. Check out lockprecision.com to find out why. Lockprecision.com. Fly higher. Fly Lock. It's time for Serious Rocketry. Serious Rocketry since 1998, providing the Rocketeer with great kits, motors, supplies, and more. They have lots of products in their ever-growing web store with fast shipping, wide selection, and courteous service. You can check out the amazing and popular Serious Rocketry kits that harken back to the days of fun-to-build detailed kits that are more than just 3 fins and a nose cone. And Gene, what did you find?
Always fun going through the Serious Rocketry website. One thing that I do check out every once in a while, not as often as I should, is on the left-hand side when you go to the seriousrocketry.biz website. About midway to the bottom, there's something on that column called Serious Rocketry Specials. It's they offer all kinds of stuff, and it's always constantly changing. So I went there today, And I found the Sirius Rocketry Eradicator, which is a very cool rocket. It's part of the Sirius Rocketry Transition series. It's done in-house, and it's a series of kits that can be flown on model rocket motors, yet can also be flown on high-power motors to help you transition into the high-power rocketry. This is a 29-millimeter motor mount. The Interrogator G was the first example of the kit, but the Eradicator is the latest addition. It flies great on F&G motors and pretty high on them. But when you really want to get your level 1 power certification, the Eradicator can fit an H motor with its 29-millimeter motor mount. What's really cool about the Eradicator is it's got a two different diameter tube transition with with strakes. I love the strakes, and some special unique fin configuration. So you've got some rings around the fins, which actually make it whistle when it goes up. I have one and I love it.
Nice.
So it's a very cool design. It's got 2 full color decal sheets. It's a lot of decals with this. So you'd have your time with it. It comes with a ripstop nylon parachute and 400-pound test Kevlar shock cord mount, which is good and strong, so it'll be able to handle it. It's about 45 inches long, 3-inch diameter on the largest tube, 29-millimeter motor mount, and weight approximately 17.5 ounces, depending upon how you build. But the parachute is 30-inch diameter ripstop nylon. On sale in their special section for $79.95. Now, I pay a lot more for mine, but I still love, well, not a lot more, but this is a really good deal on this rocket. It's a great build, a lot of fun, and it's a great flyer, especially if you like whistling rockets.
All righty.
I agree.
Sirius Rocketry's website features real-time stock tracking, which lets you order with confidence from their online store. No having to call or write to see if something is really in stock. And when you're ready to fly, Sirius Rocketry has motors and hardware in stock from Estes through Aerotech High Power, as well as popular electronics from Jolly Logic and Estes. Be sure to ask them about their club specials. Visit their websites today at siriusrocketry.biz and .com. Sirius Rocketry, for the serious Rocketeer. The Rocketry Show would like to thank the following patrons for their support: JohnRocket.com, Jason Rotney, Sean Falkingham, Joe S., Paul Olivieri, Sam Feinberg, Michael Aylward, Brian Schenkenberger, E. Hudnell, John Thompson, Mark McBride, Doug Wade, C. McCauley, Carl Hunting, the Piedmont Student Launch Team, Steve S., Chris Irving, David Simmons, SBRFusionRocket.biz, John Kucher, Christopher Short, Kelsey Black, Brian Renneker, and Jason Rodney. If you wish to show your support and become a patron of The Rocketry Show, just visit us at support.theRocketryShow.com. All right, there you go. The University of Akron Akronauts catching us up on what they were up to. Oh man, what a bummer.
Right? I know. It's so funny because it's such a beautiful facility and it's like a pilgrimage to go out there. And the same thing happened to me and my high school kids. It just didn't work out the way we had hoped. It was still a great time and a great group of guys out there, though.
Yes. So
it was a good learning experience for them, though. I mean, they got an agenda, so it sounds like they're going to be fine in the future.
Yeah,
I'm sure they are. Yeah.
Yeah, there's more you learn from the failure than a success. I mean, success is always good. It's where you pull off the first time and you feel great about yourself and you move on to the next thing. But when there's failures, there's all kinds of things you learn and change as a result.
And they're approaching it from a very scientific engineering way. You know, I mean, the way that they kind of have all the problems split up and they have different teams to do different things. It's like I'm really confident that they're going to pull off some really good stuff. They already have. And so a minor setback isn't really going to be much for them right now, but they'll come back and they're going to knock it out of the park, I'm sure.
Yeah, I'm sure as well. So, before we get on out of here, we do have some listener feedback from the mailbag, so we should probably dive into there, and then we'll go from there with other things. So, who wants to start with the mailbag?
Okay, and our first comment comes from Steven Spencer, and it's in regards to the episode where we talked about radio trackers and finding your rockets, where we talked about the Marco Polo.
Episode 101.
Steven Spencer. Yeah, that's great stuff. Steven Spencer writes, great show, guys. A couple of things to add. I use the Communications Specialist RF rangefinder, and I've never lost a rocket with it. Yes, you should have a ham license to use it, which I got. By adjusting the signal receiver and volume, I walk right up to the rocket, and it has a great range. I have observed that several people with pure GPS systems will lose their rocket as you lose signal on the ground. Mm-hmm. I have also used the Prime Tracker GPS mobile tracker that transmits its location to an app or website every 10 seconds, which is kind of cool. Since the fields I fly on are on the East Coast, have cell coverage, the signal will always have a line of sight to the cell tower somewhere. But I don't trust it enough to use it without the rangefinder included. And also for black powder calculation, I've used, it's a website for rocketrycalculator.com/rocketry calculator. It's a little dash there between rocketry and calculator.
So that line of sight loss when the rocket is near the ground is something that I thought about when designing mine as well. So the idea is as soon as you lose the line of sight from the rocket, having the base station, back at the tent with an antenna higher up in the air, usually will pick up the rocket. But in either case, if both locations lose it, they just hold on to the last set of GPS coordinates they got from the rocket, with the thought being that it'll at least get you going in the right direction. And by the time you get anywhere near that rocket or reestablish line of sight, it'll update the exact GPS location. But usually you lose it somewhere like maybe 50 feet above the ground if you're going behind a hill or something. And you're not going to drift too far away from that.
I was really surprised. Marco Polo actually retained signal after it was on the ground, and it was behind a building, and a propane tank, if I recall. But
nice.
But it retained signal the entire time. And I've talked to some of the other guys that use the Marco Polo, and they say that they haven't lost signal when it's on the ground either. Unless, of course, you're behind a mountain or something out west, that could be a little different. But so far around where we are, it's been pretty good.
What frequency band does the Marco? Did they say?
I think it's a 900 or something.
Ah, that's why. Yeah, 900 megahertz. It can. Yeah, it's a little more flexible than the really high band stuff like 2.4 gig, like I'm using. So yeah,
got it.
Yeah, it'll ping around a lot easier.
Yeah, it didn't even lose signal up to 8,000 feet. I was still getting something, which is I thought was pretty cool.
That shouldn't be a problem when it's in the air, even if it's a really weak signal, because that's true line of sight. So whatever the theoretical limit is, you should be able to hit that just fine from the air. It's just when you get near the ground with the obstructions, that's where a lot of these little details make a difference. And which is the point that Brian Schenkenberger made when he was with his email, basically saying lower frequencies like you can get with a ham license or a tech license do not have the line of sight issues of the higher frequencies. And,
what a segue. Nice.
Yeah. I really didn't plan it. I looked at it and it's like, I might as well just take that one. So yeah. So the lower in frequency you go, the more the chances that the signal can kind of distort enough to get around things and bounce a little bit easier. But the higher up in frequency you go, the closer you're getting to light. So then getting behind something becomes more of a hard shadow, which will totally block the signal versus, having enough signal escape around from wherever it is to be able to still get a usable signal from the source.
Interesting. I'll handle this next one, and then the last one, Jesse could probably handle, I think. So
sure.
This also has to do with Marco Polo. That's the only reason why I'm saying. So the next one comes in from
sounds good.
Jimmy Burgess, and it says, after losing signal on the Marco Polo radio tracker unit, how close do you have to be to regain the ping? It has a range. Like if you lose signal to the base station, it will ping like every 30 seconds if it loses it, or sooner if it loses signal, to pick up a signal. There's no range that I know of. It could be up to about a mile. So if you lose signal and you're still tracking it, the line of sight on it, it's weird because if you are more than a couple of miles away, they say it'll still pick up to a range of about 3 miles. Now, I haven't tested that out yet, but I never had any problems even losing signal, and it didn't lose signal on the ground. So probably I'm going to go with the instructions that said about 3 miles. So which is I think it would probably, I was over a mile. I was about a mile away from mine, and I still had good signal after it hit the ground.
Nice.
I know a lot of people are still talking about picking those up, so that's good information. Thanks for sharing that.
I love it. I mean, it's like I was happy when I got an extra tag for Christmas, and it came with a nice little Velcro pouch, which I didn't get on the original unit. So it fits in a pouch with 4 Velcro straps sewed in, so I could just Velcro it to my shock cord in its own little protective pouch. So
is that a weatherproof tag as well, like the original one that you got with the tracker?
Yes.
Oh, okay, cool.
It is it's weatherproof, and it's got a little Velcro pouch thing that it's solid. It's not going to come off if I Velcro it to a shock cord.
Quick question for me then. How hard was that to sync? How hard was the second tag to sync with your handheld unit?
30 seconds. Because you have 3 different channels.
Simple,
so I signed it. Yeah, I signed it to channel 3, and they even give you little stickers so you could tag it.
Nice.
This is number 3, number 2. So I have 1 and 3 because the middle one. So
for next time. Okay.
For next time, yeah. So very easy to do. So
I love it.
Good question, though.
Good questions, guys. Good questions, guys.
All right. And do you want to take the last one there?
Yeah. So Timothy Hoagland hit us up. And let me read this. It's make sure I space it out correctly. I just finished listening to episode 101 and was thinking about the claim that vertical ground testing represents a worst case scenario. Since once the rocket is in the air, the ejection charge doesn't have to push up the nose cone, but actually pushes down the fin can. I think that a horizontal test actually represents a worst case scenario because in that orientation, gravity isn't helping separate the rocket. Maybe I'm thinking about this wrong, but it may be an interesting topic in the future. Okay, so I will need some help answering this question, but one of us responded, and
yes, I did.
Let me read the response. Oh, okay, cool. Thanks, CG. So the response, let me read that. We'll answer on the show, but to clarify how we test vertically, the fin can is stationary, and the nose cone payload section is the part that moves from the firing the charge. Otherwise, yes, pushing down the fin can is effortless. Okay, so can you iterate on that a little bit, CG?
Basically, for me, on my rockets, and I'm not, everybody's rocket's a little different, but on mine, the fin can part is usually the lighter part, so that's going to go. So the heavier part's going to be the upper half with the parachute, main parachute fairing and the electronics and everything else. So I figure if it can move all of that away from the fin can, then it's definitely got enough oomph to do whatever it's got to do in any other position it might end up in. At apogee. So that's kind of what I was getting at by being worst case scenario.
So I've done my fair share of ground testing, and one of the things that I've always done is, I'm going to say put it like at a 45-degree angle against one of my rocket stands, and then just kind of anchored the fins into the ground on top of a blanket or something. And it's usually a fireproof blanket, but you guys know what I'm talking about. And it creates that angle, but in most cases it always fires and then kicks back the fin can into the ground. So I guess I have to try it vertically. But I understand what you guys are saying. Just
keep in mind that you have to make sure that you have... that you give things an opportunity to move out of the way, because it's like it's vertical, but it's ever so slightly not when I do it. So because I don't want the upper half to come back down on the booster,
down. Right,
and scrape up the booster. So
so maybe a 2 to 5 degree angle, perhaps instead of
fire away from the crowd. No,
yes,
pretty much
exactly. Yeah,
just like your pads, like your So.
All right. Thanks, Timothy.
Yeah, it's an interesting point, though. And primarily, though, the fact that you're asking about it is good. Just test. Test the way you feel comfortable. And if you feel comfortable with your test, I like to do mine vertically. That's me. If you prefer to do it horizontally, that's you. And everybody's got different reasons for why they do it.
And most people do it horizontally anyway, I've noticed.
Yeah. Yeah, well, it's easier to do that way because you can do like Jesse and put the blanket down and protect the fins as they're kind of going in the ground at an angle or whatever. So I usually use a box and I go vertically. And most of the times when I do my testing, I don't test the bottom section for the drogue. I just test the parachute section, right from the nose cone, the main section usually. Because if I use the same amount of powder for each, unless it's a crazy rocket. But if 2 grams of black powder is going to kick out the laundry and the top section, it's going to kick out the bottom section. That's just me. So
Right,
I'll make sure because you've got a lot of like extra pressure with the parachute packed in and all your Nomex and blah 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 up in the top section and a shear pin perhaps or 4. So if it can push all that out at a decent distance going straight up, then that's the logic that I use. But again, everybody's different. As long as you're testing, that's the important thing.
Yeah, for sure. I have tested the payload on a phenolic rocket, that Big Nuke 4 that I always talk about. I did have those 3-4-40 shear pins on there, and the charge that I had was able to, cut those pins and separate the payload. Separate the payload with the electronics bay from the booster. It worked, and I did use that calculator that was shared earlier. So.
I use the Andrew Kleinhans method. More powder.
Right. More powder. Do it till you lose it.
We'll put a link to that rocketry calculator in the notes for the episode too, so that you'll have access to that.
Yeah, everybody, please go to the actual webpage after you listen to the episodes and review the notes, because we put pictures and all kinds of funny stuff on there. So visit the webpage.
Maybe an Easter egg or two. Who knows?
Yeah.
And the episode and the page for this will be theRocketryShow.com/102. So just so you know.
Perfect. Cool, guys. Thank you. Good questions, everybody. Send us more.
Awesome.
Send us tons more.
We like them. We answer them.
It makes things much more gooder. Alrighty. So for the next episode of the Rocketry Show, it'll be Joe Barnard stopping by, giving us a little bit of a hint on what he's up to.
Sweet.
All the times we've had him on here and there and talked to him, it feels like we've had a whole episode with him, but we've never really had an entire episode with Joe. So this will be the first time on the program. So looking forward to that one. Yeah.
I never even realized that. I mean, he's like a part of our DNA,
Right,
We kind of started all at the same time. It's funny.
Yeah. So that's what's happening on the next episode of the Rocketry Show. Keep an eye out for that in your podcatchers. And if you like the show, please tell a friend about it. Let other Rocketeers know about this program. Because let me tell you, we have a nice little fan base. Not as many people know about the show as you would think they do. would. So spread it out. Spread out the word. Get it out there.
Please.
Tell a friend.
I try to spread it around too, guys. I mean, yeah, I tell everyone. I think everybody in our local club down at SCORE knows, there's that Rocketry Show guy. So when I get to wear t-shirts now, and then when some of our other members wear the Rocketry Show t-shirts that you can get from...
Well, shirts.theRocketryShow.com.
Thank you so much. Okay. But anyway, we have a few club members that have ordered those t-shirts, so they probably go up and talk to them. So that'd be kind of funny, but you guys can always ping me too, We got
sweatshirts too. I got a beautiful one.
Yeah, so that's another way to spread the word is, go shirts.theRocketryShow.com and order yourself a nice Rocketry Show t-shirt, sweatshirt. You can there's quite a few options there. Or you can make your own and put our logo on it, whatever you want it on. So have fun with that and spread the word. Let folks know. So anyway, on that note,
keep your eyes in the skies.
All right, we'll see you next time for episode 103 of The Rocketry Show at TheRocketryShow.com. Stay safe.
Have a comment? We'd love to hear it. Send them to mailbag@TheRocketryShow.com. If you enjoyed what you heard, don't forget to check out our sister show, TheModelRocketShow.com. The Model Rocket Show is hosted by the Rocket Noob and is all about low to mid-power rocketry. TheModelRocketShow.com with Daniel, the Rocket Noob. Check it out today. The views and opinions expressed on these programs are those of the participants and do not necessarily reflect those of Little Beth Entertainment or its sponsors.